good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever with part 2 of quadratic equations. Let's get to it, shall we? The great ABBA and Waterloo still playing. Alrighty then. Let's see. We can do the same thing here. It's a little bit more tricky with an exponent, I'm sorry, not an exponent, a coefficient of your squared term other than 1. So what I'm going to do is make it 1. And how do I make it 1? Well, I can multiply through everything by -1/3 or divide everything by -3. I think that's easier to show. And so then I have x squared, and 12 divided by -3 is -4. I'm going to leave a space here. 5 divided by -3 is -5/3, and 0 divided by -3 is 0. So half of -4 is -2, and I square -2 and I get 4. So again, I'm going to add 4 to both sides, and to compensate, I'm going to subtract 4 from this side. So now I factor this. X minus 2, the quantity squared, comes from here. That's the whole reason I did that. -4 minus 5/3. Well, -4 is the same thing as -12/3. So that's going to be minus 17/3 is equal to 0. I'm going to move over here a bit. So x minus 2 squared is equal to 17/3, adding it to both sides. X minus 2 equals plus or minus the square root of 17/3. So x equals 2 plus or minus the square root of 17/3. Booyah! Done. Yes, you could have used the quadratic formula here. But completing the square is a valuable tool, as we will see later in this course. Quadratic formula, right here, it is on your formula sheet for you right here. You always know it if we're in the form of, or you always have it. If we are in the form of ax squared plus bx plus c equals 0, we can find the roots, the solutions for x, by using the quadratic formula. It is a beautiful proof. I will not take time on the video to do it, but there it is right there. And in fact, we prove it by completing the square and doing some very simple algebra. I encourage you to pause and see if you can follow through on this. It's a beautiful, beautiful proof. Using the quadratic formula, I'm just going to do one of these. I'll do this one. Ax squared plus bx plus c equals 0. So a is equal to 2, b is equal to 3, and c is equal to -6. So x equals -b, so that's going to be -3. Now if this were -3, then this part right here would be +3, plus or minus the square root of b squared, which is 9, minus 4 times 2 times -6, a is 2, b is -6, all over 2 times a. So I got to clean up in here, -3 plus or minus the square root of 9. 4 times 2 times 6 is 48. How do I know it's positive? Because I have a negative times a negative here, which is a positive, all over 4. This equals -3 plus or minus the square root. 48 plus 9 is 57 over 2, which is a perfectly acceptable answer. I don't believe that, no, 57 can't be simplified, so we are good there. You can always use a calculator to solve a quadratic, and let me just show you this real quick. I have my GDC up, okay, and I have it open to Scratchpad on purpose. I want you to stop using Scratchpad. I want you always to use a document, and it's just so important, and you'll see later on in the course and how I explain it in class. So I'm going home, new document, And I'm going to show you how to do it using a calculator. And then I'm going to show you how to do it graphing. Menu. Got some algebra going here. Polynomial tools. And I want to find the real roots. We're in the real number system. We're not in the complex number system. So we're always going to choose real roots of a polynomial. Okay. Polyroots. Okay. And we're going to solve this one, x squared minus 5x equals 6. So I'm going to do x squared. I'm going to enter that. Minus 5x minus 6. And then I'm going to hit a comma, and it has to be in terms of x. And I hit enter, and I get the roots. Is that the greatest thing you've ever seen in your life? It's -1, 6. How about that? Okay. Now I'm going to add a graph to show those roots. Control, and I go to document, and I want to add a page to my document, and I'm going to add a graph. I'm going to graph that, and it was, I have a short-term memory issue, x squared minus 5x plus 6. So x squared minus 5x plus 6. Boom, chugga-lugga-lugga. Did I do that right? I feel like it was minus 6. Yeah, minus 6. Okay, so I messed that up. So I'm going to hit tab to fix it. I arrow up and delete, make that a minus. Life is good. And you can pretty much see where the roots are. Again, the roots are where the function is equal to 0. And the value of a function is always its y value, its y coordinate. If you're not convinced, we go to Menu, Analyze Graph, and we find the zeros. Lower bound, in other words, I go to the left of the x-intercept, drag to the right, and I get my solution -1. I have another one over there, Analyze Graph, find the 0, left of the intersection, right of the intersection, boom, chugga-lugga-lugga. And there we have it. I'm going to copy this real nice for you and put it so you have it to see. And that's the other, whoops, that was awkward. So you have it that way, or we go back here and you have it this way. Now, I'm going to show you something else. This is a big reason why you should always work in documents. We have this function as the first function, f1 of x. Look what you can do, okay, if it's already entered on a graph. If you already have it as a graph, you can go Menu, Algebra, Polynomial Tools, Real Roots of a Polynomial. So same thing, polyroots. But I can type in f1 of x, put that in parentheses, comma x, enter. Look, I get the roots because the calculator knows since we're in a document, we're referring to this function. So a great tool that we can have. Very, very powerful, especially later in the course. All right, hope you enjoyed that. Let's check back in with ABBA, see how they're doing. Waterloo. Not if I wanted to. I hope you enjoyed it. We'll see you next time. And I am out.